Hi everyone, and welcome back to the Chapter 7 video lectures. In this video, we're going to explore how forensic anthropologists go about building a biological profile for unknown remains. One of the primary reasons that forensic anthropologists are used to assist in forensic cases is to build a biological profile. To do so, they must answer two questions. Are the remains human? And then, who do the remains belong to? Let's start with how forensic anthropologists determine if the remains are human or not. Let's say a hunter comes across a skeletonized hand in the forest. The hunter brings in the bones to his local law enforcement office. If the bones are human, they need to investigate and they need to start looking for missing people. If the bones are animal, though, then it's not a criminal concern. The officers are unlikely to have the training to make a distinction, so they can call on a forensic anthropologist as a consultant. How will the forensic anthropologist determine whether the bones are human or not? One of the ways that forensic anthropologists can identify human bones is to look at the composition of the bones themselves. This is to help determine if the bone is human or animal. For example, this cross section at the top is a bird bone. Notice that this bone is not very dense. It has extensive air pockets. This type of bone composition helps reduce the weight of the bird and it aids in flight. Human bones, on the other hand, are much more dense with very small air pockets. Forensic anthropologists will also use the shape and the size of the bones to help distinguish between human and animal bones. This slide here shows you some common animal arm bones. You can see that each has a similar number of bones, but the structure and the formation of the bones are much more unique. Distinguishing between humans and other mammals, though, is much more difficult because mammals tend to share similar bone structures amongst themselves. For example, the hand bones of a human and a bear are very close to one another. You can see a lot of similarities in the shapes of both on the slide. However, forensic anthropologists are trained to identify the unique characteristics of human bones, so they can be a really useful resource for investigators. Now, having a full hand, a forensic anthropologist training will definitely help them differentiate between mammalian bones and human bones. But oftentimes, forensic anthropologists won't be given a full hand. Instead, they may be given pieces or even a single bone. Differentiating between human and animal bones becomes increasingly more difficult as the number of bones becomes smaller. For example, if you find a full skeleton of a human, it's a lot easier to identify specific bones that make it uniquely human. However, in scattered remains cases, we may only uncover a few skeletal pieces in the area, and that makes it much more difficult to identify the unique species. This is particularly true with infant bones, which I want to cover on the next slide. So the most common human bones to be mistaken for animal bones are bones from infants. Why? Well, part of the problem is that infant bones are incomplete. An adult human body contains approximately 206 bones. However, infants, they contain more than 400 bones. Why so many? It's because in an infant, some of the bones have not fused together yet. These bones include the end of the long bones, as well as bones of the hand and the feet and the clavicle that aren't fused. So they don't look human. To the untrained eye, the small infant bones can often be confused with smaller mammals like raccoons, rabbits, or even birds. The skull can also provide some confusing bones for an infant human. Infants are born with pieces of the skull bones separated, and they'll fuse together as the child grows. The separate pieces can therefore be confused with a tortoise shell. Infant bones are also thinner in cross-section than adult bones, again mimicking some smaller animals. Now, once a forensic anthropologist has determined that the bones are human, the next question to be answered is who the bones belong to. Now, I'm not going to go into depth with these very much because your book provides you extensive details, and this week's activity will have you researching the photographic differences between male and female skeletons, as well as adult versus children skeletons. But overall, there are a number of markers on our skeletons that can give a forensic anthropologist clues about the individual's identity. This is presented in what they call a biological profile. Some basic identifying characteristics are shown here. The bone structure of males versus females differs, both in size and the shape of certain bones. Anthropologists can use the bone fusing status as well as dental progression and bone characteristics to help make an age determination for the skeleton. And they can also estimate the racial identity and special identifying characteristics of the remains based on the skull, the bone length, and some other deformities. The features on this last slide can help a forensic anthropologist provide some class characteristics to help identify the body. But what would individualize the remains to a specific person? That's going to involve a comparison process of several items collected from the remains to official records of various types. For example, photographs, x-rays, dental impressions, fingerprints, and other specimens will be taken from the remains themselves. These are then compared with missing person databases, police records, school records, that type of thing. Facial recognition is also an extremely useful investigatory tool because it can be age progressed as necessary to help with identification. Medical devices can also be extremely helpful because many of these contain a unique serial number that can be used to identify a specific patient. Now I want to focus on facial reconstruction for a little bit because it's a personal interest. I was really interested in this topic when I was in graduate school, and I got the opportunity to take a facial reconstruction course from a reconstruction artist at the National Center of Missing and Exploited Children, Joe Mullins. Now, Joe does two primary types of reconstruction. The first are age progression photographs. Joe will use photographs of children and teenagers that have been reported missing, and he creates age progression photographs that show the person in current times. There's a lot of art involved, as Joe has very little to work with when he does the progressions. He uses photographs of the parents and typical aging patterns to help estimate the final reconstruction. Age progression photographs are usually done when the person is still missing, in the hopes that someone will identify the age progressed photograph and make an identification. But Joe also works with skeletal remains to help investigators identify deceased victims. That process is shown here. Traditionally, the skull is covered with tiny markers, and these markers depict the depth of skin in different areas. The marker depth is determined using the person's sex and ethnic background. These markers help the reconstruction artist create a clay reconstruction, which can then be compared to photographs of missing persons. Here are some age progression examples from the National Institute of Missing and Exploited Children. While we commonly use facial reconstruction techniques to age progress missing persons, like I mentioned, we can also use the same techniques to age progress perpetrators if we know who they are. This can be particularly useful in cold cases where we have old photographs or video of the perpetrator and we're trying to find the person years later. And age progression can be done for any age range. This age progression photograph was completed from the baby photo that was shown here. The parents' faces are used to help extrapolate what the child would look like. Now, as I mentioned before, this is a lot of art as well as a forensic science skill. And I want to highlight the skill and the artistry involved in creating these reconstructions. So during my class, we actually got the chance to reconstruct the skull. All of us were given the same skull, a mass-produced prototype, and we were given guidelines that this was an Asian male teenager. And then we were asked to reconstruct the person's face. There are known average skin depths for different ethnic, gender, and age groups. So we were able to put all that information together to do that skin marker process. The old school and the highly technical method is to use erasers cut to different heights and attach to the skull in different places. And these provide a guide about the clay thickness in each area. Then the facial features like the eyebrows, the lips, the nose, all of these are added on top of the skull. Again, there are no distinct guidelines for these features, but the reconstructionist will use the characteristics of the skull to select appropriate features. Now here's the key. Notice that we were working with the same guidelines and the same skull, and not a single one of our skulls looked the same, even though we were all using the same guidelines. Here's the facial reconstruction that our instructor did, following the exact same guidelines. And here's a photograph of Joe Mullins. In this photograph, he's working on the newest version of facial reconstruction, in which instead of creating a physical clay model, reconstructionists will actually use a clay model on the computer. And that provides a much more versatile image that can be age progressed more easily. Now, one of the major challenges for victim identifications occurs when a forensic anthropologist is presented with what we call commingled remains. Commingled remains means that there are multiple people's remains mixed together. This can be a few people's remains overlapping, like a grave used for a single family, or it could be hundreds of remains mixed together. Sometimes mass commingled remains can be a product of natural history. For example, consider the Black Plague. When the plague epidemic started, cities would start losing massive numbers of people at a very rapid pace. And because the plague would spread so quickly, the city used large mass graves to hold dead bodies because there simply wasn't enough time or labor to individually bury everyone themselves. Commingled remains can also result from wartime atrocities and mass murders. Mass graves are used in wartime crimes, like when hundreds of prisoners are executed into a single large grave. So how do forensic anthropologists determine if they have commingled remains? Well, first, they're going to have to organize the remains, using the bone characteristics to lay out the bones in a normal skeletal pattern. There are several clues that indicate commingled remains are present. The easiest is a higher than possible number of bones. If the bones are laid out and there are 3 femurs, then bang, we definitely have another set of remains mixed in with the body. Anthropologists will also look for discrepancies in the size of paired bones and vertebrae. For example, if there are 2 thigh bones, but one is significantly larger and longer than the other, this may indicate either a physical deformity or it could be evidence of commingled remains. Forensic anthropologists will also look at the biological profile. So they'll look at differences in sex, age, and race differences in the bone characteristics. Now here's an interesting fact about commingled remains. The U.S. military takes commingled remains really seriously. When they bring home soldiers that have died overseas, they have a policy that all bones are DNA'd to ensure that every bone sent home to a grieving soldier's family is that of their loved one and not another combatant or U.S. soldier. All right, well, that concludes the second lecture video for Chapter 7. Please join me in the final lecture video as we discuss how forensic anthropologists identify time and method of death for skeletal remains.